Alright, welcome to the last video in this module 5 of the init program. In this video we're actually going to create our own script from scratch, and this program is going to calculate compound interest. There are two types of interest, simple and compound, but I find that simple interest is very easy to calculate. So we're going to use this to calculate compound interest, which is something that people could utilize in their daily lives. So the first thing we're going to do is actually create a new file so we don't mess with the things we've already made. And we're going to name it calculate_interest.py. Make sure you have the .py to indicate it's a Python file. Click enter and you should come up with this file right here. Now the first thing that I always like to do when I'm doing some type of calculation script is figure out what variables I need to actually perform the calculation. So I have this website pulled up here, the Math is Fun website. And it provides you a great formula for compound interest. So future value on the right is what we want to calculate. And the math that we have to do here is here. Present value times 1 plus the interest rate. And that quantity is being raised to the power of the number of periods. So interest rate, you can think of it as a percentage rate or the percentage interest. And the number of periods typically is calculated annually, so it's the number of years. So we can go back to our code and we have three variables. We have present value, which is how much we started with, and we can just say this is 1,000 right now. Then we have our percentage rate, which we can do percentage rate, and we can say that is 7%, so equals 7. And then we can say number of years, so just years is equal to, let's say, 4. Now it's time to do the math. So let's start with the right-hand side of the equation, or the right part of the calculation, which is a 1 plus r raised to the power n. So we'll start with a parentheses 1 plus percentage rate, and for Python, raising to the power, you use two multiplication signs, and we're raising it to the number of years. One thing to note is that percentage rate in this formula is not necessarily correct because it needs a decimal, not a percentage. So to convert a percentage to a decimal, we just divide by 100. So 7% becomes 0.07. So you just go ahead and divide by 100, and you put that in its own set of parentheses just for enhanced clarity. So now that we have that half of our formula, the only thing we need to do is multiply this entire quantity by present value, just like the formula said. So present value, the multiplication operator. And we can also use some more parentheses to make everything clear. So we can make this right value and surround it with parentheses like this. So we have this outermost parenthesis, and you can see how Rebel sort of highlights the matching parentheses sets, which can be useful when you have a lot of them. Then we have this next set, which is just around the 1 plus the percentage rate, or the rate converted to a decimal. And then we have the most inner set of parentheses, which is dividing by 100 to get a decimal. We're then multiplying this by our present value, and we can set this equal to our final value variable. So we can name it final value is equal to this. So we can do all the math and set it equal to that variable all in one step. Now that we have this, we really just want to display this to the user. So we're going to use a print function, and we're going to use a formatted string, which we just talked about. So f and then a quote, and then we'll start off with something like you will have a $, and then we're going to have the curly bracket because we want to output the value that is actually stored in our final value variable, not its name. So we're going to do final value in curly brackets. So we will have dollars, whatever that amount may be, in. Then again, we're going to use curly brackets and put in years, and then years again like normal text. So just to go back over this string one time, you will have $, is all normal. We have final value in curly brackets, which is going to tell us what amount is actually stored in this variable. And then in is normal. The years is in curly brackets because we want to print the number that's stored in the years variable. So in this case 4, and then years like a normal string. So we can actually go ahead and run this one time just to see how it looks. And so this is also a good place where we can start looking at something called the shell. So if you go to this little question mark in the bottom right and you click on workspace shortcuts, you'll see these come up, and you'll see open shell is Control-Shift-S. So go ahead, click somewhere that's not in this pane, and click Control-Shift-S all at once, and you'll see this come up. So you can make it bigger. This is more of a traditional shell that programmers would use in a system when they're running code or messing around with files. So you can see you have runner at REPL.it, which is like a user essentially, and you have the init, which is the name of our program. The first command that we can run in this shell is ls. So type in ls, hit enter. You'll see two things come up, the calculate interest.py and the main.py. So ls just lists the files and folders that are in the current directory that we're in. So we only have two files, which you can also see over here. And now we're going to go ahead and run the calculate interest.py file using the Python calculate interest.py, just like that. Go ahead and click enter. And you'll see you will have 1,310.79 ... dollars in 4 years. So exactly the way that we wanted it to look. But there are a few issues with this output. Firstly, we don't want this many decimal points after 0.79 because you can only have 1 cent. You can't have a smaller value than that. So we need to fix that. And the other thing is that all our numbers right now are coded into the script. So there's no way for a user to actually get a value for their specific numbers. So let's start out with that. And if you remember, the way to get input is using the input function. And you can give the user a prompt. So we can do enter the initial value like that. For percentage, we can do input enter the interest rate, and in parentheses as a percentage. Notice these are all in quotes, so they're strings. And then you can do input enter the number of years, like that. Now the only thing we have left to do is that by default, Python will not necessarily know what format we want this input to come in. And since present value could have cents, it should be a float. Percentage could be a decimal, it should be a float. And you could have part of a year, so that should also be a float. So to do that, all we have to do is use the type conversions we talked about in video 1. So float, and then wrap the whole quantity in parentheses like this. So float, open a parentheses, go to the end, final parentheses. And do this for all three. And so this just makes sure that the code knows that we want floats to come in, and this way our math will be consistent and we can account for decimal values. And we can go ahead and run this one more time. So Python calculate interest.py, and you'll see that enter the initial value prompt. We can do 1,000 again. This time maybe our interest rate is 5, and maybe we're only doing 3 years. So now you'll see you will have this amount in 3.0 years. It does make it 3.0 because it's a float. There are ways to get around this with conditions, but we're not going to worry about this just yet. For right now, I think it is perfectly fine to leave this with a 0.0. So the last thing we need to fix is the very long amount of decimal points we have. We only want 2 decimal points after the actual decimal. So what we're going to do is use a function called round. And so typically we think of rounding as rounding a number to the nearest whole number. But round in Python lets us use the value that we want to round and a second argument, so comma. And since we want 2 spots, we're going to put in a 2, like this, put it in parentheses. So we don't need to go into a lot of detail about how the round function works right now, but all you need to know is you can put your value in, which is our final value, put the number of decimal spots you want, which is 2, and the name of the function is round. And if we go ahead and run this again, let's try it one more time. So 1,000, 5, and 3 years, and we see we're now down to $1,157.63. So very clean setup, and it is the correct number of numeric items after the decimal point. And there are multiple ways to actually format a float or a decimal number because people have this type of issue in other cases. And things like the format function, which we talked about in a previous module, are one example. But I think that the round is the easiest way to do it for right now, and so that's what we're going to use. So now that we have the basic functioning code, the only thing that we can add here is we can make this code run repeatedly. So if a user wanted to do this process over and over, then we can use what we talked about, which is a while true loop. And we use a while true, and we have a colon here to indicate that this is all inside the while true, and then we tab this whole thing. So go ahead, highlight all of it, and click tab. Now you'll be tabbed one over, and you'll see this line come up, so that shows you that this is tabbed over one time. And if we run this now, so you can also hit up on the arrow key when you're in the shell, like this, and it will give you the last command you entered, so we don't have to keep typing it in. So it will automatically come up with Python calculate interest.py. Hit enter. Let's say we do the same thing, so 1,000, 5, and 3 years. We get our output, you will have this amount in 3.0 years. And then we immediately go back to the enter the initial value, because while true keeps the loop going over and over. And so we can have a user just continue to use this. And so this kind of system is used in programs that need to sequentially keep running, or in websites where you don't necessarily want the entire program to shut down after one iteration. And so we could then enter a new set of numbers, 1500, and maybe our interest rate's 8, and maybe we have 4 years. We'll get another output, and we can do this over and over. Now, if we want to exit, because there's no real way for this to exit, then we can type in or hit Control C on the keyboard. It will give us this keyboard interrupt, which is something we have briefly talked about in a previous program. But then we'll see we're back to the runner@REPL.it, so our code is no longer running. And we have actually built a small little script that calculates compound interest. And you can see that it was not super difficult. We used mostly concepts that we talked about in booklet 3. We used operators here. We used assignments with the equal signs. We used a formatted string. But obviously, we did not go into super detail about input, but in general, input's pretty easy to understand. All you have to do is enter a string as a prompt, and Python will know that you want the user to enter input. We also talked about type conversions, which is something very, very useful. As you can see, we used it 3 times here. And we could do a different type. We could maybe say integer. Maybe we want people to only use a whole number of years, so we could just go ahead and change this to int. Really, the possibilities are endless, but I hope that this shows you that even with the amount of information you have now, you're already ready to start building basic programs. And as we continue to build and learn more information, obviously our programs will continue to grow and we'll develop something that will maybe be a little more impressive. But this was really just a demonstration to show you that you need to work in a sequential manner. You need to understand what you're trying to do, make sure you have the necessary values, and then you can always go back and make the code more complicated. Like in this case, we started out with single numbers like 1,000 and 7 and 4, but then we went back and added input. So you can always make changes to your code. I also think that it's important that you guys understand that the shell and how it operates, it's a much better system than REPL's sort of default terminal that they have here. And from now on, we're going to be using the shell. So you can also use the shell in very similar ways like we've talked about in previous programs. So like clear, we'll clear the shell. We'll talk about more commands as they become necessary for our code. But I hope that this video teaches you both the basics of creating a script from scratch and for using the shell to run your scripts.